Hello Professor, my name is Deepthi and today's topic of presentation is fading and path loss in VANET. The overview is I'll be talking about the basics, introduction, propagation models, and we are proposing a paper. In this paper we are proposing something called corner, and we'll talk about the reverse geocoding, propagation situation classification, formula application, sample propagation, and the connectivity experiments which and the link quality, the VANET simulation, and the conclusion. We do the VANET simulation comparing the corner with the other flat propagation models. VANET. The problem with the VANET is the mobility, which causes the path loss and the fading, and we talk about communicating with the vehicle to vehicle and vehicle to infrastructure. Then we talk about the path loss. In communication systems, the attenuation undergone by an electromagnetic wave is transit between a transmitter and the receiver, and that is also called an attenuation factor, and it is caused by diffraction, reflection, refraction, and absorption. And we talk about the fading. Fading is nothing but the fluctuation in the signal strength because of the variation in the transmission medium, and the mobility and the probability are the key for the performance of the VANET vehicular network protocols and applications. Here we are talking only about the urban areas, and in the urban areas there are a lot of vehicles and a lot of applications. In the vehicular networks we have a lot of a lot of buildings and vehicles, so the signal will be reflected and diffracted due to these obstacles, so we cannot ignore the buildings as such. So, and we have to take into consideration all the reflective indexes and the materials used in the buildings and so on. So the city scenario is characterized by a lot of cars, non-uniform density, and irregular propagation obstacles. It is imperative to learn the to study the scalability and performance of the applications and protocols that run on such scenarios. Simulation is an essential tool to study the behavior and evaluate the performance of protocols and applications in a large-scale urban vehicular networks, because the realistic experiments are very expensive, so everyone are digging into the simulation tools in the market, and we use QuailNet simulator in this paper. In the urban scenarios, as I told, the buildings cannot be ignored, and the possible path loss can be accurately calculated using ray tracing. These techniques require detailed information about the environment, like the reflective index, the type of materials used, the scope of the buildings, and more details are required for ray tracing. And gathering information is a difficult task, and it requires a lot of resources allocated to them, and it's difficult to store the information in the database too. And when a radio wave hits it's an object with a larger than the wavelength. Much of the energy of the wave is reflected in a direction that obeys the Snell's law. The Snell's law is nothing but to describe the relationship between the angles of incidence and the angles of refraction through a isotropic medium. and this is the Snell's law. So when a ray enters the surface of air and some other medium like glass or something, so some of the part of the ray is refracted and some will be reflected. So which causes fading. And the multi-path fading is usually a problem only in the narrow bandwidth communication. So we use a wide bandwidth physical layer. So if the signals get cancelled out, so if we take a wide bandwidth area, the signals which are not cancelled out are utilized. In multipath fading models accounts for the variation of the received signal power due to the small movements of the receiver or reflective objects. And another concept is called shadowing, and shadowing is nothing but the decrease in the received signal because of a large obstacle in between the transmitter and the receiver, and receiver is in the shadow of an obstacle. And there are two propagation models which are ray tracing and ground reflection. And ray tracing is a method, as we see in the figure diagram, that the source radiates rays in all different angles, and some of the rays will be reflected, and as we see there is a lot of gap between the rays, so that's called the mist area, and we consider a technique to reduce that mist area. And ray tracing models the transmitter as a source, and it determines the paths taken by these rays. In the urban area, the loss along each path due to reflection, diffraction and scattering is determined, and because of this ray tracing we can determine the path, the loss due to scattering, diffraction and everything. And because ray tracing finds the path of each ray that travels between the transmitter and the receiver, it yields very accurate estimates of the path loss. But the contrary is, it is very complex because it takes into account each and every ray. So the alternate to this is called beam tracing, where it takes into account each and every it does not find the individual paths from transmitter to receiver, but it tracks the beam of rays. In ground propagation, the free space propagation model assumes that the received signal power decays like the reciprocal of the distance between the source and the transmitter, and this one is very critical because some of the rays